Now that we know how to do the distributive property with expressions, we're going to go back to what we started the year off with, which was writing expressions from words. So here we are again with words, and we have to come up with an expression. Okay, now since we're in the distributive property section in the book, probably we're going to wind up with a distributive property type situation in these expressions. So just be aware of that. The directions here say write and simplify an expression and indicate the properties used. So we're doing three things here. Come up with the expression, simplify the expression, and then tell what properties you used in order to simplify that expression. Okay? So here we go. We have twice the difference of 3x and y increased by 5 times the sum of x and y. So you need to remember how to do these. Where do we start? Start with the variable. In this case, there are two variables, right? X and y. Okay, so start with a variable. It says twice the difference of 3x and y. So that's like one part. Then we have increased by 5 times the sum of x and y. The thing that I boxed, increased by, what does that mean? Okay, so I'm going to put a plus right here so that I see that I'm going to do something here, and then I'm going to have plus, and I'm going to do something here. Okay? All right, twice the difference of 3x and y. How can I write that? Well, how do I write that, though? I got to come up with a good way to write that. Because it says twice, right? Twice means 2, just 2. What am I doing with that 2? Multiplying. Twice means double it, right? Times 2. But it's twice the difference of 3x and y. What does difference mean? Difference does not mean divide. It means we're going to subtract. What are we subtracting? We're subtracting 3x and y. So that means I have 3x minus y. What am I doing to 3x minus y? Nope. We're multiplying it by 2. It says twice the difference of 3x and y. So I find the difference of 3x and y, and then I got to double it. And the way that I'm going to write that is that. Okay, so that takes care of this first piece. I see this plus sign sitting here, so let's put a plus sign there, and let's move on to the second piece and see if we can come up with what that should say. 5 times the sum of x and y. So what are we doing with x and y? We're adding x and y together. The sum of x and y is x plus y. What are we doing to the sum of x and y? Now we're 5 times the sum of x and y. So now we put parentheses around that sum, and we say 5 times whatever that is. Okay? So, write the expression. We did. And simplify the expression. That's what we're at now. And then also indicate the properties that you use. So, if I want to simplify this thing, what can I do? Distribute. So we have what? 6x minus 2y. I did that. 2 times 3x is 6x. And then I did that. 2 times negative y is negative 2y. Because what is the number in front of that y? Actually, it's negative 1. But yeah. So 2 times negative 1 is negative 2y. Now what? So what do I write here? Plus. And then, good. 5 times x is 5x. 5 times 1x is 5x. And then 5 times 1y is plus 5y. Okay, now I got to say what property that was. So this is step 1 right here. 1, the property that I used was the distributive property. Okay, step 2, now what? I said it last time, I'm going to say it again. After you distribute, you always combine like terms. So step 2, we already know what the property is going to be over here. We're going to say combine like with a dash terms. Like terms is kind of like one word, so you put a hyphen in there. All right, do we have any like terms to combine? Yeah, what do we get? 6x and 5x combined to give me 11x, and then I have negative 2y plus 5y. I have a negative 2y, and I have a positive 5y. When I put those together, I get positive 3y. Watch your signs. That's a negative 2. The sign goes with the number. That's a positive 5. The sign goes with the number. Negative 2 plus 5 is positive 3y. And that's as far as we can go. X and y are not the same variable, so we cannot combine those. They're not like terms. That is now simplified. Okay? So 2 steps. We show them. 2 properties. We show them. I'd like you to work on the second one with a partner, the person you're sitting next to. Again, just one more time, as you read the problem, try to mentally form a picture of how this is going to work, okay? I have 5 times, well, 5 times what? Then it goes on to the difference of n squared and r. So the way that that's worded tells me that this is all one thing right here. 5 times the difference of n squared and r. And the way that I just read that tells me it's going to be 5 times, and then the n squared and r are going to go together in some fashion, all right? Then I have plus. So this is a new thing. This whole thing goes on the left side of the plus, and then the rest of this, 8 times, again, the sum of 3n and 2r, that will go on the right. So this is actually, in this case, where I would start. Now, 5 times the difference of n squared and r, we need to know what difference means. It means subtract. What are we subtracting? We're subtracting n squared and r. So I'm going to write n squared minus r. Same order that they wrote it in, because of the way that they worded it. Now, what am I doing to n squared and r? Whatever it is, I'm multiplying it times 5. The actual n squared minus r, whatever that is. So that means I have to put parentheses around it so that the order of operations tells me that this has to happen first, and then I multiply it times 5. That takes care of everything on this side of the plus sign. So now I go to the other side of the plus sign. It says 8 times what? 8 times the sum of, sum meaning what? Sum means add. So I'm going to add 3n and 2r, the sum of 3n and 2r. So I write 3n plus 2r. And what am I doing to 3n and 2r? Whatever it is, I got to multiply it times 8. So just a little bit of thought, and remembering what those words mean. If you don't remember those words, you have them all written down towards the beginning of your note packet. Go back and review those words. You got to know them. Okay, we're ready to go here. What do we do now? You need to distribute first. So we'll distribute. We have 5 times n squared, which is 5n squared. And then 5 times negative r is negative 5r. The sign goes with the number, so remember that. Okay, we have the plus sign here. Plus. So that's a positive 8 times 3n, which is 24n. And then a positive 8 times a positive 2r is, so plus 16r. All right, and that is my first step. So over here, I'm going to call that, and I don't have room, so I'm going to abbreviate, distributive property. Okay, next step. All right, if we have like terms, combine them. Do we have like terms here? Okay, so I'm going to write step 2, and then I'll combine those like terms, and over here, I'm going to write combine, abbreviated, like terms. Okay, I see this 5n squared here. Do I have any like terms of 5n squared? No. The exponents don't match. So I don't have like terms of 5n squared. That's fine. I just rewrite it. Okay, now I move on. What would be next? Okay, the minus 5r and the plus 16r will combine to give me what? 11. So that's positive 11r. Anything else? The 24n. I know my r's and n's look kind of the same, but this is an n right here. Do I have any like terms with the 24n? No, so I just rewrite that. Plus 24n. Okay, that's it. There are no other like terms to combine, so this is our answer right here. When you see problems like this with this sort of set of directions, this is what they're asking you to do. So I expect to see the original, I'd expect to see your steps, and I need to see them labeled. All right, we're going to change gears a little bit here. Not really, though. I'm going to try to teach you how to do a little bit of mental math. I've said before, the more you can use your brain, the faster you'll become, and actually the more powerful you'll become in mathematics. So I'm trying to teach you how to use your brain to do multiplication like this. How many of you would reach for your calculator if you saw 7 times 49? Probably everybody would, okay? But you can use the distributive property to actually do mental math and be able to do a problem like that in your head. And really, fairly quickly, if you get good at it. If you keep practicing at it, you'll be pretty good. Okay, so to do this, rewrite the problem using easier numbers. Then use the distributive property, and then combine like terms. All right? Now, in a problem like this, it's all going to be like terms. You're just going to put it all together in the end. What I mean by using easier numbers is not change the 49 to 50 or something like that. That would be called estimating. What I want you to do is change 49 into 40 plus 9. So this becomes 7 times 40 plus 9. Do you guys agree that 40 plus 9 is 49? Okay, so is this the same thing as what I have written here? Okay, now if we distribute, can we do 7 times 40 in our head? What is 7 times 40? Good, 280. And then 7 times 9 is... This is where knowing your multiplication tables comes into play. 7 times 9 is 63. So I have 280 plus 63. Can we do that in our head? What do you get? 343. Okay? We didn't use a calculator. We used the distributive property. The mental math that came in was this. And this is how I do math like this in my head quickly. I'll split this number into easier numbers, just like this. You don't have to visualize this in your head, just know how to do it. 7 times 40 is 280. 7 times 9 is 63, and if I put those together, I get 343, right? So that mental math just made me more powerful as a mathematician. Use the distributive property to evaluate something like 44 times 2.5. So to do that, would you reach for a calculator probably on this problem? Probably, okay? But if you use mental math, we can split 44 times 2.5 up into two problems that we can do very easily. 44 times 2 plus 1/2. Stick with the fractions. The more you work with fractions, the better you will become at them. So that by the time you get to Algebra 2, it's going to be easy. So now we distribute the 44 times 2, which is, all right, we know that one, that's easy, 88. 44 times 1/2, in other words, half of 44, which is 22. So now we have 88 plus 22, which is 110. You can use this mental math when you are paying for a bill at a restaurant and trying to figure out what the tip is. You can use mental math to figure out what your grocery bill is going to be fairly easily, actually, and fairly accurately. It's a good thing to know how to do, because then you'll know if somebody's trying to swindle you or not. Use the distributive property to evaluate 21 times 17. Two numbers that you don't normally multiply together. What could we do? Okay, 21 times 10 we could do, right? But 21 times 7, do we know 21 times 7 pretty easily? No, not really. So there's actually a better way to break this thing up. So I'm not going to break the 17, right? What if I broke the 20? What would I write? 20 plus 1 with the 17 back here. Is that still the distributive property? Yeah. Can we do 20 times 17 pretty easily? You think so? What is it? Working with bases of 10. We have 17. If this was 17 times 2, what would you get? 17 times 2 is 34. So 17 times 20 would be 340. All right? Remember those base 10 rules. So we have 340, and then 17 times 1 is just 17. So we get a total of 357. Recognizing how to break up a problem and use your brain. Way more powerful than reaching for the calculator every time. Let your brain grow, okay? The last thing we have to do is learn how to rewrite some fractions. This is a very important skill to know because in algebra we work with this sort of thing constantly. You're not going to be able to reduce fractions like you normally do, but you do still reduce fractions. It just looks different. So remember that a fraction can act like a grouping symbol. We remember that, right? The fraction bar is a grouping symbol. It groups the numerator and the denominator separately. And that a fraction a over b can also be written a times 1 over b. Do we understand that? Just to make sure we do, if I put that a over 1 and then I multiply that out, what do I get? I get a over b. I get the exact same thing back that I started with. Okay? So we need to know that we can go from here to here in like one move. It doesn't take any effort. You just kind of separate them out. So we're going to use that to rewrite fraction expressions. Find an equivalent expression. We have 7x plus 2 divided by 5. So the 7x plus 2 is all divided by 5. So I'm going to use this idea here of a fraction being rewritten like this to make that 5 go where? 1/5. That's right. It'll be 1/5 times 7x plus 2. That concept right there is so important in this class. Put a little star next to it or a sunshine, since we have no sunshine today. Write important next to it. Where are your notes? That's not good. Come to class prepared. Okay, from here now we're going to distribute. So we have the 1/5 and we're going to send that in. 1/5 times 7x is what? 7/5 x. And then we're going to, so that was this. We're going to distribute there too. What do we get? So plus 2/5. If you notice what kind of happened here is it's almost like I just took this fraction bar right here and I split it into two separate fractions. So I'm getting rid of that fraction bar and I'm putting the 5 under each one separately. You can kind of think of that as being what happened there, okay? But in reality, the math that happened is we moved that out so it would be a 1/5 times, and then we use the distributive property to bring that back in. So this would be a shortcut of the actual math that's going on. All right, so what is my first move here with the second one? What should I do first? Without the shortcut. Good. Move the denominator of 3 out front, so I write 1/3. What? Times Minus 16, perfect. Okay, and now I can distribute. What do I get? 4 over 3 m minus 16 over 3. And that's your answer. Also remember that now we're looking at fractions that we need to reduce. If they reduce, you have to reduce them still. How about the last one? What do we do? 1/12 times. All right. And wow, that's supposed to be a 12. Okay, now what? 15/12 plus 6 over 12, and I'm going to write the y like that, which is exactly the same as 6y divided by 12. All right, these are the same. Okay, is that my answer? Probably not. What do we probably need to do here? So the word we're looking for is reduce fractions. They're not like terms. You want to reduce the fraction. So we have 15/12. Does that reduce? Yes, it does. To what? Right, the factor here is 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. So it reduces down to 5/4 plus 1/2 y. Or if you had the 6y over 12, that would reduce down to y divided by 12. Y 12ths. All right, that's it for the section.